Speed cubing is the task of solving a Rubik's Cube as fast as possible. Cubing is of great interest to robotics, as it requires precise manipulation. For example, if the face is not properly aligned after a turn, it can prevent the next face turn. Making turns on a Rubik's Cube quickly is an even greater challenge. Currently, there are two notable cube-solving robots. The first robot was made here at MIT. Wow, that's really fast! But isn't that kind of unfair to humans? We don't have 6 hands, let alone 6 limbs, and our wrists can't rotate like motors. The second is OpenAI's robot hand. Its hardware is more fair to humans, but it is really slow. Introducing SpeedCuber Bot. It aims to be a balance between the two robots. With only an arm and a gripper, it has a hardware limitation like the OpenAI robot, but it aims to make fast turns like the MIT robot. Before we get started, we need to understand move notation. U means to turn the upper face 90 degrees clockwise. U prime means to turn the upper face 90 degrees counterclockwise, and U2 means to turn the upper face 180 degrees. Before we can make a turn, we need to constrain the layers that will not turn. Initially, I was planning to have a second evil arm hold the cube in place. However, after receiving the model of the Rubik's Cube and finding out the grippers cannot really grip onto the cube, I decided to make and use a box that held the bottom layer in place. Because of this, SpeedCuber Bot will only be able to turn the top face. To make a U move, we move the gripper to the grasp position for a U move, grabs the cube, make a clockwise turn, and ungrabs the cube. To make a U prime move, it is the same except we move the gripper to the grasp position for a U prime move and make a counterclockwise turn. To make a U2 move, we can do 2 U moves or 2 U prime moves. Our goal is to make turns quickly, so we should turn in the opposite direction of the previous move. This is because after completing a turn for a U move, the grasp position for the U prime move is closer than the grasp position for the U move and vice versa. With this plan, we can model the motion of SpeedCuber Bot as a state machine. Additionally, to actually get the gripper to those positions, we solve inverse kinematics as an optimization problem to get the joint position for the desired pose. Putting it all together, we can give SpeedCuber Bot a sequence of up-face moves and it will execute them. The worst case turn time is 0.9 seconds, but thanks to the optimizations we made for U2 moves and the fact that going from U to U prime and vice versa is faster, the average turn time is 0.77 seconds. While a 0.13 second time save on each turn seems very little, it adds up when doing a sequence of turns, and speedkeepers are looking to save every little second. SpeedCuber Bot is not perfect, as it only successfully executed the given sequence 63% of the time in testing. However, the fact that it succeeds more than fails when executing a sequence of 30 to 50 turns is a promising result for the future of SpeedCuber Bot. To progress SpeedCuber Bot, we need to fix the simulation of the Rubik's Cube. Then, by adding a second evil arm, SpeedCuber Bot will be able to turn multiple faces, not just the top face.